Here is few party questions from the paper electricity. The first question is, what is Wheatstone bridge? Wheatstone bridge is an arrangement consisting of 4 resistances that can be used to measure one of the resistances included in the bridge in terms of other resistances. See here, P, Q, R and X are 4 resistances, but the values of P, Q and R are known. X is the unknown resistance. To determine the value of X, we have to use this formula, X equal to R into Q by P. The second question is, what is potentiometer? The potentiometer is a device that measures the potential difference between 2 points. A potentiometer is equivalent to an ideal voltmeter. Third question is, what is meant by EMF of a cell? Electromotive force of a cell is the potential difference across its terminals when no current flows through it. If you measure the voltage of a cell when no current is passing through it, that is called EMF. Suppose an amount of current is passing through the cell, an internal resistance is developed. As a result of the developed internal resistance, the voltage of the cell is dropped. Therefore, electromotive force tells us the value of voltage without internal resistance. State Faraday's law of electromagnetic induction. The rate of change of magnetic flux linked to the closed loop is equal to the EMF induced in the loop. The induced EMF is equal to minus d pi by dt. Suppose an amount of current is passing through a closed loop, magnetic flux is induced. If you change the amount of current, the value of magnetic flux generated in the loop is also varied. As a result of this varying magnetic flux, an EMF is induced in the loop. The induced EMF is given by the formula minus d pi by dt. This is our Faraday's law of electromagnetic induction. Now, define self-induction. We may modify this Faraday's law of electromagnetic induction in terms of self-induction. As we discussed earlier, suppose a current is passing through a closed loop, magnetic flux is induced. The rate of magnetic flux generated is proportional to the amount of current passing through the loop. More is I, more should be the value of pi. So, to remove the proportionality sign, we are introducing a constant L called as self-inductance. So, pi equal to L into I. Now, this Faraday's law is modified as the EMF induced equal to minus L into di by dt. State Lenz's law of electromagnetic induction. The statement of Lenz's law is the direction of the induced current flow is such that it opposes the magnetic flux which causes the current. To realize this law, consider a bar magnet. This is south pole, this is north pole, and one coil. If you move the magnet towards the coil, current is generated in the coil. The produced current may generate a magnetic flux or magnetic field. Here the north pole is generated. The north pole may oppose the north pole of the magnet. If you move the magnet away from the coil, the current produced in the coil may generate the south pole and the attraction is predominant. Therefore, the direction of the current in the coil may oppose the magnetic field generated by the magnet. Now read out this statement. The statement of Lenz's law is the direction of the induced current flow is such that it opposes the magnetic flux which causes the current. If the magnet is moving towards the coil, a current is generated. The generated current may produce a magnetic flux. That magnetic flux opposes the magnetic field generated by this bar magnet. If you move the bar magnet away from the coil, instead of repulsion, attraction is predominant because this coil generates south pole. Next question is, define mutual inductance. When two coils are brought closer and if the current in one coil changes with time, the flux linked with the second coil also changes. As a result, an EMF is induced in the second circuit. This phenomenon is called mutual inductance. Here, a current is passing through this coil. As a result of this current, magnetic flux is generated in the second coil. The value of current passing through the first coil is changed. The flux linked with the second coil is also changed. As a result of it, an EMF is induced in the second coil. This phenomenon is called mutual inductance. Next question is, what is a transformer? A transformer is used to get either a high AC voltage from a low voltage AC source or a low AC voltage from a high voltage AC source. Transformer has both primary and secondary circuits.